Hello everybody, thanks for joining us on this webinar where Dr. Ocker, our course tutor, will be answering your questions on choosing the right microscopes for live blood analysis. So my name's Elizabeth Clemens. I'm the presenter of the Live Blood Online 12-week training course where we teach live and dry blood analysis to people all around the world. If you'd like more information on that, please see our website or email me for information. So we get many questions about choosing the right microscope for live blood analysis. So we decided to put this webinar together where Dr. Ocker will really explain what is needed. We do realize that a microscope is a big investment, and this can put people off if they don't know or don't feel confident that they're making the right choice. So I'm going to ask Dr. Ocker some of the questions, or some of the most common questions, and some of the questions that you submitted. You can submit questions throughout the webinar. What you need to do is locate the questions box in your panel. There should be a panel there, and there is should be an icon with I think it's a hand. So if you can locate that and pop your questions in there, we'll endeavour to answer them throughout, and if not, we'll answer them at the end. And if you want to pop a question in the question box, I'll just say OK, just to let us know that you have located it OK. OK, good. So I can see somebody's hand there. Yeah, just put a quick question in the box just to let us know that you're all okay. All right, so handing you over to Dr. Ocker now. Hello, Dr. Ocker, what do you have for us?
All right, well, thank you, Elizabeth. Well, you know, with deciding on a microscope system and what is actually suitable for live blood analysis, perhaps the best place to start is actually to look at some images taken with two different types of microscope systems. So that's what we have on the screen here.
Oh, I see. So could you explain to us why there's such a vast difference between the two images, please?
Yeah, of course. Well, what it really comes down to here is the type of microscope system that was used. The one image on the left-hand side was produced with just a standard type of microscope. The image on the right-hand side was produced with a microscope specifically developed for live blood analysis. Now, what I've found over the years researching different types of microscope systems is that most of the so-called dark field microscopes are not actually suitable for live blood analysis. Now, the image on the right is what you really need to achieve with your microscope system if you were to use live blood analysis to its full potential.
I see. So there's an immense difference between these two images. The red blood cells in the image on the left seem to be far too small, and there isn't enough clarity to be able to see anything within the plasma. Does this illustrate why it's so important to have a suitable tool for the job?
Yes, definitely. You know, using a microscope like the one that produced the image like this for live blood analysis is really like trying to use a tennis racket to play golf.
Absolutely. So can you briefly explain what the main differences are between the two microscopes in this example, please?
Yeah, sure. Okay, so the microscope here on the left was actually a 20-watt halogen lamp as the light source, and then it used a dry dark field condenser, and also very importantly, it had a standard 1-to-1 magnification ratio between the eyepieces and the camera. Now, what this last bit means is the microscope has been designed to produce the same magnification on the screen as what you would get through the eyepieces. Now, this is actually a very standard feature with most microscopes because with most applications, it would actually demand for this type of setup. The specifications I just mentioned are what most microscope systems are actually set up with. That's most of the standard laboratory microscopes. The image on the left was produced with the HD LED microscope system. Now it has as a light source a 9-watt LED lamp, and the brightness here is actually equivalent to a 100-watt halogen. So this is actually 5 times stronger than the microscope on the left. Also in the dark field condenser was an oil immersion dark field condenser, and also then the magnification ratio is 1:4 magnification ratio between the eyepieces and the camera. Now this is very important because this means that when you use the 40 times objective, you're able to achieve a magnification of 1,600 times on the screen. Now as you can see from these images, that really makes a very big difference.
Yeah, it certainly does, doesn't it?
Absolutely.
What else do you have for us?
Right, well, we're going to go on to just 3 other images. And these images show a particular area in the sample, again with different microscope systems and settings, just to show you again the level of clarity that you're able to achieve with different microscope systems. And just to clarify that the images that we're seeing here have been scaled down just to make them smaller so we can fit them on the slide here. But the edges of the images is actually what you will really get on your screen. And you can see the difference in magnification there very, very clearly. All right, so the arrow is...
Sorry, what's the difference in the microscopes between these 3 images?
All right, well, let's go through that. And just to point out, the little arrow is actually indicating a white blood cell. And you can actually see the size of that cell is really very, very small in the first image on the upper left-hand side. So let's go through the settings of the microscopes. All right, so again, the image on the left here was produced with a standard 20-watt halogen microscope, again with the 1:1 eyepiece to camera magnification ratio. But here we used an oil immersion dark field condenser. Now this is a higher quality dark field condenser, but because of the weak light source, the dark field image is still not nearly close to where it should be. The second image, all right, the second image again, this was taken with an HD LED microscope system specifically developed for blood analysis. So a 9-watt LED light source, an oil immersion dark field condenser, and again the 1:4 eyepiece to camera magnification ratio. So in this image, a 40 times objective was used, giving us a magnification on screen of 1,600 times. And this is the magnification that we would be using during most of the analysis. So you can actually see the shape of the red blood cells clearly, you can see the white cells clearly, and all the structures between the cells and the plasma are fairly easily identified and differentiated. But if you were to see a specific cell or a microorganism, this is where we then increase magnification, and this is then where we get this high level of magnification. So this is the same type of microscope that was used, HD LED microscope, but here we were using the 100 times objective, which gave us an on-screen magnification of 4,000 times.
Well, that's a huge difference. To summarize then, what specifications are needed in a microscope system for LBA? Just to summarize, please.
All right, we'll go through the most important ones. There are variations between the specifications of some of the microscopes. We look at the objectives and all these types of things. But if you really want to be able to use blood analysis to its full potential, these are the most important ones to look for. So we have 5 points to look for. First and foremost, perhaps one of the most important things would be the light source. It needs to be strong enough for dark field, And the minimum requirement there is 50 watts halogen, but ideally a 9 watt LED, which is equivalent to about 100 watt halogen is the most ideal setup. Secondly, an oil immersion dark field condenser. Thirdly, it's actually very important to have a wide range of magnification available to you. So we have 5 plan achromatic objectives. So the individual objective magnification should be 4 times, 10 times, 20 times, 40 times, and 100 times. Very importantly, the 100 times magnification objective needs to be an oil immersion objective with a built-in iris diaphragm. And this again is a very important feature because most of the standard 100 times objectives don't have a built-in iris diaphragm, and that allows through too much light, and then again you're not really able to see anything very clearly with this objective. Fourth point there, a very important one, we need a 1 to 4 eyepiece to camera magnification ratio. So in other words, when you're looking through the eyepiece, you would see about a quarter, you would see about a much larger field of view than you would see through on the screen. On the screen, you would get about a quarter of the field that you would see through the eyepieces. So there's an additional magnification going through to the camera, which then gives you that really great magnification on the screen, which is really what you need. And lastly then, a high-definition digital camera is needed. Also very important to have a user-friendly interface so that you're not distracted from the analysis by having to adjust things on the software. And also the camera needs to have a wide enough sensitivity to allow for dark field imaging. Because of the low amount of light actually going through the sample, the camera needs to be quite sensitive to be able to work properly for dark field.
Okay, so just to mention that the HD LED system that we supply is equipped with all of these features, isn't it?
Absolutely, yeah. It's specifically been built for live blood analysis in bright field and dark field, and then dry blood analysis as well.
Okay, good. Well, we've got a few questions here. First of all, what are the factors to determine the cost of a microscope?
Well, there are quite a few factors involved. One of the first things would obviously be build quality. Some of the microscope manufacturers do cut some corners and cut some costs, and that means a microscope that's not always reliable and will not be suitable for very long use. But then there are a few other more technical specifications that we would need to look at. So let's go through those. The first one to mention perhaps would be the objectives. Now on a microscope, the objectives are the lenses that are usually found just above the stage that provide the different levels of magnification. Now the most basic entry-level type of objective is called achromatic. Now this means that only the central 60% or so of the image will be focused and color corrected. The remaining 40% of the image around the edges will appear blurry. Now in the slightly more expensive semi-plane objectives, the correction is about 80%. We have 80% of the image at the center that will be in focus, with the remaining 20% being blurry. Now the most expensive objectives are called plan achromatic, and they produce an image that is 100% flat, and that's in focus and also color corrected. Now what they also mean, another interesting point here is with color correction, in color corrected objectives, the colors of the spectrum will be visible in the viewing field. So it's corrected so that all the colors are visible in the viewing field. So in other words, the cheaper objectives, the achromatic objectives, where only the 60% of the central area of the field will be in focus, only 60% of that field is also color corrected. Now this means that color of objects around the outside of the area would not really be correct. The other important issue with regards to objectives is the numerical aperture. This simply determines how much light an objective will allow through. Now this is also quite standard for most objectives, but when it comes to dark field, we need a lower aperture for the standard, or than the standard for the 100 times objectives, and this is what we mentioned earlier. But if you use a standard 100 times oil immersion objective in dark field, you would not really be able to see much at all unless you're able to adjust the aperture. So this is where the built-in iris diaphragm comes in that allows you to adjust the aperture and reduce the size of the aperture. Without this feature, 100 times objective is actually of very little use in live blood analysis.
So does that answer the second question, which is why are cheaper microscopes not suitable?
Yeah, I think it goes to answer some of that. You know, most of your cheaper microscopes are really built for the demand that is out there, and the sort of standard demand for a laboratory microscope is really the sort of standard setup that one that is really easily available, and that's the 20-watt type of microscope. That doesn't really have high quality lenses and doesn't really have the wide magnification range that we need for blood analysis. So supply and demand does play a role there. You know, the type of microscope required for blood analysis, there's not really a very big market for that, and we actually have our manufacturers specifically build these microscopes to our specifications.
Okay, because we get a lot of attendees that go out and see if they can find a cheaper microscope deal, and they do actually get told by the suppliers that these microscopes are suitable for dark field. I mean, are they intentionally deceiving people, or?
No, I don't think they are. You know, I think they're just not really involved in the field of blood analysis, and they perhaps don't know what is really required to be able to analyze blood samples, live blood samples, properly in dark field. These so-called dark field microscopes might work for other types of samples and other applications. But when it comes to analyzing live blood, we really need a very high degree of brightness and contrast in the sample to be able to see everything that you really need to see in the sample very clearly. Most of the anomalies in dark field that we really need to pay attention to are actually very, very fine and very small, much smaller and finer than the red blood cells and other structures in the blood. So they're not really easily visible unless you have a really good quality blood analysis system.
Okay, and that answers the next question, which is what's the reason for the higher price tag on live blood analysis microscopes?
Absolutely, yeah.
Yeah. Now, how important a role does dark field play in live blood analysis?
Well, it really is a very important feature. You know, dark field analysis is something that plays a central role to the analysis that one does in live blood. There are actually some anomalies that can only be seen in dark field. There are some anomalies that can only be seen in bright field as well. But it really is very important to be able to do dark field, because many of the anomalies that you're able to only see with dark field often would determine the direction one would take in terms of treatment with a case. So usually we would start with a live blood sample and spend a few minutes in bright field just going over the sort of main features in the sample. And you know, once we've perhaps looked at the sample for about 10 minutes, we'd go over to dark field. And that's where things really get interesting, and we go through the deeper signs in the sample then. And as I said, you know, what you see in the blood often here in dark field would determine the treatment that you would take with the case.
Is it true that some anomalies can only be seen in dark field?
Yeah, absolutely. There are quite a few anomalies that are really only visible exclusively in dark field, and they only become visible in bright field when they're at a really extremely high degree of development. You know, so when things have really progressed far past the point where you want to be able to detect them at.
Thank you. And can you tell us about cameras and what to look for, please?
All right, sure. Well, very important, as I mentioned earlier, not all cameras are suitable for blood analysis. It's very important that the camera has a wide sensitivity to be able to accommodate and handle the low light conditions that we have in dark field. Otherwise, you won't really be able to see very clearly in dark field on your screen. Another feature that's very important is the frame rate. So if you especially start looking at digital cameras, USB digital cameras, they would often have a very high resolution, but usually you would sacrifice your frame rate the higher the resolution becomes. So often we would find cameras that claim to have a 15 megapixel resolution, but the frame rate would be around 2.5 frames per second. For live blood, when we're actually looking at a live video feed from the camera on the screen, you actually need a frame rate of about 25 frames per second or more. Otherwise, if you have a frame rate less than that, the camera is only really suitable for still images, nothing that involves any type of movement.
Okay, so there's quite a lot to look out for. So our microscope system that we recommend also includes the camera, doesn't it?
Absolutely, yeah. The standard features are the higher definition type of camera with the HD LED system, and these cameras also, very importantly, are compatible with all operating systems, Apple and Windows, and even Linux as well.
Okay, and we have a question here about cameras. I already have a microscope. It's a trinocular LOMO microscope. What I don't have is a suitable camera. Can you give a make, model, and supplier, please? I don't know if you maybe want to reply to that via email, or if you can answer that now.
Yeah, we can reply to that on email. We do have suppliers depending on the type of camera that we use, so I can give details on the specifications on the camera and so on.
Okay, so if you could email that question into us, please, and we'll answer it for you. So any more questions? Please put them in the box if you have any more questions. That seems to be it for the moment. If you do have any more questions, then please email us at info@livebloodonline.com. So thank you very much for joining us. We hope that's been useful to you. Please let us know if you would like to know more or want any more information or any help in choosing the right microscope. All of our microscopes are available at www.livebloodonline.com, so go and have a look there and let us know if you would like to know more about our 12-week training course. Our next course begins on the 27th of September. So anything to add to that, Dr. Ocker?
Well, just that we are available for any type of questions, so if anyone wants to discuss different types of systems, if they found a different microscope and would like to know whether it is compatible, we're available for any advice.
Okay, well, thank you very much for that, and thank you very much for joining us. So it's goodbye from me and a goodbye from Dr. Ocker.
All right, thank you very much. Goodbye.
Thank you and goodbye.